My name is Jaume Coloma. I'm architect. I'm the CEO of the Envelopes Textiles, a company focused on the production of light sunscreen facades and other systems of pergolas or for interior walls. In the project of Plural, we have been playing the role of manufacturer of a new solution that we have developed specifically to achieve the results that the project is searching for. Well, in the project, we have achieved the developing of a new approach to renovate facades, full facades. In terms of that, the envelopes was initial thought for a light sunscreen solution. And now within the project, we have developed a completely solution to make a ventilated facade where we have add new functional functions that before we didn't used to have. The main achievement, it's within that it's have done a new approach to do this type of renovations, since mostly of them are done by frames, we have the height of one floor. And in our case, what we propose is to do like very large screens modules to the renovation, and even also from a lighting solution. Most of the standard solutions for renovating facades are more heavy in terms of loads, and our ones is lighter, thinking about making easy to adapt in all buildings. Yeah, and this project, of course, has been the change to test this new approach about doing these large sequences to renovate facades, but adding more functionals, like as I will explain later, like adding louvers, adding photovoltaics, adding unit ventilation systems, and other main things. Well, the added value of the project for our organization is have the power of all the consortium partners. I mean, this is a great change to be able to work together with a lot of companies and organizations that knows a lot about renovating facades, and the best is that between everybody, we have been trying, we have find the best chances to develop something interesting and functional for the market. In terms to resolve the main objective of the Plural project, which was to reduce the installation speed and even the cost. At the time, we developed NZEP facade system, in order to reduce the consumption of the buildings, of maybe all buildings. Well, the added benefits of our technology related to the occupants that we have been trying to resolve is to give to the users more isolation for the buildings, which means by adding great thickness of insulation, and even this isolation installed under a ventilated facade. We also have given to the occupants of the building more glass protections by installing a double window, which increase the isolation of the windows, even the sound isolation. We also in this area of the glass, we also have developed a new system of louvers with our system, which also increase the protections against the sun over the windows and even the noise. And another main area, very important, it's been to install in our system an energy saving system made by new unit ventilations that allows to renew the air of the occupants, while the heat is not low, so it's the cheapest way to do it. And the last one, no less important, it's been to add PV tiles in our system so that we can create energy to reduce to create green energy. We all know about the benefits of the photovoltaics, and we already have integrated this technology in our facades. On the other hand, we now have talked about the occupants, but from the point of view of the technologies, the solution we have developed within the Plural project and with all the partners, it's being able to do a new architectural design for the renovation of the buildings, in which highlights the safe energy consumption by, as I said, increasing the insulation and giving a ventilated facade, a double window, and louvers. We also developed a system that it's very interesting because it saves cost and installation time when do the installation or even the production, and also all these things in a lighter solution, which is about 10-15 kilos per square meter, which makes it reliable or it makes easy to install in all type of buildings because it's a light solutions, as I said. And another good point is that the system we have developed is also registrable. It's made of a lot of small tiles, but each tile can be easily registrable, so that it helps to have access to the interior of the facade for many tasks, for maintenance, for improving, or wherever you need. Also, this registrable solution allows you that when you are within the louvers, you can easily take out or add tiles in order to have more or less light according of the outside condition. If it's summer, maybe you want to have more shadows, but maybe if it's winter, you want to take out some tiles so that you can have more light inside. And the last one is that our system is 100% recuperable, and it's easy to recuperable, and sorry, I don't have the word. And it's easy to recyclate. Yeah, it's easy to recyclate. There is almost no all the solutions can be all the attachments can be easy disassembled, so it makes easy the recuperation of all the materials. And lastly, as it is a system designed 100% by digital skills, and the production of our components, it's also 100% by CNC machines. It allows to ensure that every kilogram of material we use for the project is optimized. We just produce the material in the sections which are required to achieve the best rendement of the materials. And another two good skills about our system, the system we have developed, is that we install it without almost not doing disturbances for the final users. The system, mostly maybe at 90%, can be installed from outside, so that we can do the renovation without producing disturbance in the final users. And it happens the same for the street users. No, it is fast installation, so we reduce the problems of having to cut the streets for the traffic cars and whatever. And that's one of the most important things about the added value of our technologies. The lessons we have learned in the project is that maybe for us it was the first time we participate in a big consortium, European project research. We are very thankful for having had this opportunity. And maybe the main work is for us, it's been the first time we have been working with such a big teams, which at least we have seen that it requires to prevent as much as possible the future steps of the decisions we make. I mean, this must be understood, since that every decision you take, it affects a lot of partners, which are doing a lot of grit and hard work, and you must be really secure and safe about what you do, because it is linked to all the other partners, and it's must be taken. These decisions must be taken seriously, no? And the other lesson we have learned is that the inertia of the project is big. I mean, maybe it's related in the first point. So the inertia is big. So once you take a decision and the project goes on, and maybe you need to change it, you have to have really good skills in adaptation and innovation in order to solve the new requirements without having to delay all decisions. The next steps we're planning to do about all the results and the designs we have done and achieved within the project is the first step is like just do something like waiting, or like to see how to get more feedback about how the project or what the job we have installed in the demo site will work during the next year, just to ensure that everything is okay, and getting more data to know that all our innovative installations has worked correctly, and they can be used in another projects, which we have much confidence it will be this way. And of course, after that, for sure, we will add this new develop solutions in the Plural project to insert these new functionals in our catalogs, and also share the new data we are having in the catalogs in order to try to do new projects and to try to make profit and share with all the sector of the construction and architects and everybody who can use the gains we have developed for the system during the last years. Finally, our next step is we will keep being aware for new research projects to improve the work we have done. We have realized that the physical of the project is what we did is really good, but we know that more work can be done in terms of digitalization. Right now, it's everybody's talking about artificial intelligence, and since our project is 100% digitalized, I mean, it's made and it can be produced with CNC machine. There is a really a good chance to incorporate all of this power of artificial intelligence to our system. It's not this process could be not only useful to get more aesthetics, also would be very interesting to make all the process design like automatic, so that we could even reduce more the cost of designing, the cost of making the design of the projects with more accurate, and also could help us to do better calculations for the dimensions of the system in relation of the wind loads, or in relation of the PV production we can produce, or the use of the unit ventilations and other siting systems. Yeah, this is our last step we expect to do, and it will help really us to have a good product for a good system, no, for the market.
So my name is Daniel Philippen. I'm a researcher at SPF, the Institute for Solar Technology at the Eastern Switzerland University of Applied Science. our institute came up with the idea of the external wall heating, which is a prefabricated facade module, which includes a heating layer which can heat an existing building from the outside after the facade module is installed during refurbishment. And another topic we brought in the project was a simulation framework called PyTransis, which is based on the simulation software Transis and was further developed by our institute. So regarding the connex wall, the prefabricated facade module, we solved the question how to prefabricate the whole facade module and how to integrate this heating layer onto the facade module in a way that it can be prefabricated, pre-installed at the manufacturer and brought in one piece, the whole facade module, to the construction site and then be installed on site. So this simulation framework PyTransis we further developed within the PLURAL project, and we provided this simulation framework to our project partners within PLURAL, so they could use it as well for the system simulations of the development. Well, basically we were solving the question how to install or how to develop this heating layer on the prefabricated module. So the facade module was brought in by RDR, our project partner, and together we discussed how to include this heating layer onto the facade module. And there were lots of questions also regarding ventilation and windows, so all the functionalities which are included in this facade module. And for us, it was very helpful the exchange, professional exchange with all the partners from different disciplines, from science, but also from on the manufacturer side. So there was a big exchange and a good learning curve which together we went through. The added value of the technology is that, especially for buildings, existing buildings, which have radiators inside and anyway should be thermally insulated, our technology can bring in a solution with many functions. So an existing building can get a new thermal insulation, and between this new thermal insulation there's a heating layer added, which then through the old facade is heating the building from outside, let's say. And this is very beneficial, especially for buildings which have radiators inside before. And anyway, these radiators, when changing to a non-fossil heat distribution or heat provision, like you want to switch from gas or oil to heat pumps, there you want to have a low temperature distribution for the space heating. And for this you need either a floor heating, or with our technology you can get this low temperature heating from outside through the old facade. And together with this new facade module and the heating layer, you can also add the new windows which are already pre-mounted in these facade modules, and also decentralized ventilation units with heat exchange can be pre-mounted there. And also you can have PV modules mounted then as outer layer, so you also get solar energy used in terms via PV panels. Yeah, this planning of this prefabricated modules was somehow challenging because there are many disciplines included, so there was quite some planning in advance, because we add a new construction. So with this new facade module, you also add windows and ventilation units, and all has to be, or some of these components have to be electrically connected within inside the building. So there were several disciplines that had to be coordinated. This was somehow quite challenging in the project, but we solved these issues. So the lessons learned is with this prefabrication, you you gain a lot of time on site, but in advance you need to invest quite some time, especially if you do this the first time, to coordinate all these different partners and disciplines. So for us, there are still some steps to do regarding prefabrication and or industrialization to produce these facade modules. Now we have a good solution which was developed during this project, but for sure there are others or steps to do to get to the prefabrication cheaper or easier. So we are looking forward to hopefully with partners from the project to go steps further to bring the solution in short time to the market. It would be nice to see.
I'm Jan Včelák, and I'm from the Czech Technical University in Prague, and we are part of University Center for Energy Efficient Building, where I work as a team leader. I was work package leader for work package 2, which was related to development and designing of the technologies that are going to be used within demonstrations in Plural project. Well, this is pretty good question. I think we are still not at the end what we wanted to achieve, and I think that the main aim of the project was to put together the technologies, the innovative technologies, but also some of the state-of-the-art technologies to work together in one system. And those technologies were designing to be applied finally in the demonstration project. So within work package 2, we were really focusing on development and designing of the technologies for cooling, heating, and air handling that are being further on use on the real buildings. Apart from cooling and heating, we were also focusing on the renewable energy sources that are necessary part of any NZ building today. The answer for that question would be quite straightforward and easy, because for the first time within this project, we were able to apply the innovative technologies that we have developed here. So first time we applied the air handling unit with thermoelectric active heat exchanger. This is the first application of 6 units on the real building that is going to work in Terasa demo. And also for us, it was first time where we applied the technology of the wall heating together with SPF, because it's also not a standard technology that is that would be being used for a couple of years in Czech Republic. It's really an innovative solution, and we are really curious how it's going to work, and we want to have the real data to compare with other systems. Well, in that case, I think that's the basic question that we need to put at the beginning of the research project. What will be the outcome, and how beneficial would be the outcome for the final user or end user of the project and technologies? And for us, even if we are not the final user in this case, I think that we want to offer the users to live in a healthy conditions, in a healthy environment, but under the lowest cost, operational cost as possible. And this is focused on the cost for the energy that they need to pay monthly for the energy that they consume in the house. But we want to assure that the people and inhabitants living in healthy conditions, in fresh air, and they pay as less as possible for the energy. So that's the reason why we need to apply also the renewable energy sources together with other advanced systems like heat pumps and etc. in the system. The added value of the technology might be the better usage of the renewable energy sources, especially in the case of our designed air handling unit, because from the very beginning it was designed in a way how to use the solar energy, PV energy, to power up the cooling system of the houses. That was the original aim of the unit, to really efficiently use currently produced energy from the PV source to cool down the buildings, because the match in that case is perfect. You need to cool down the building in the time where there is a high irradiation, high solar gains. So this could be one of the case how the technology could have added value for the occupants in terms of the cost they need to pay, and also in terms of how to use the renewable energy sources. Definitely, we coming from the academic environment. One day, even the academics has to meet the professionals in the field. And the comparison of the perspective from the engineers and designers with respect to the view of the academics and the researchers might be really very different. So for us, it was a really challenging but also like exciting process how to transfer the technology that is being developed on the academic institution, how to transfer it to the praxis, to the real market. What would be the obstacles that you need to overcome if you want to put the innovative new product on the market? How well it will be accepted by the wide public? How well it will be accepted by the standard designers and the engineers? So this was, for me at least, it was the main lesson that we learned, how to really put something from the academic to the real market, and what obstacles and barriers you need to overcome. Not only the technical barriers, you need to, I would say that most of the time you are facing the barriers from the designer's perspective. You're bringing something new to the market, and obviously nobody trusts you that it might work, and how it will be working in the future, how it will be maintained, and what would be all the issues that might rise in the future. So all this you need to overcome, you need to explain, you need to promote. So this was for me at least the big lesson that we need to go through.
I'm Kateřina Sojková. I'm also from the Czech Technical University in Prague and the University Center of Energy Efficient Buildings, and I'm focused on building physics. I'm a coordination manager for Kašava demo building in Czech Republic. I managed to coordinate a team of professionals who participated in preparation of technologies for Kašava demo building, and this coordination resulted in a renovation, almost renovated house, is gonna be one of the most innovative in Czech Republic, perhaps, which combines various technologies which are not so common in building practice, but they are much more innovative than common, and put such technologies together with let's say common practitioners was quite challenging, but I think it can work. We somehow managed to be in quite close contact with professionals from practice. Quite extensive exchange of experiences happens during the practitioners and between the practitioners and theoreticians from the university center. And I think this exchange quite enriched both parties and whole our team For me, communication and coordination of team of various specialists from different fields, different countries, different backgrounds, more combination of practitioners and theoreticians was really challenging, and during the time it forced me to become assertive and keep the point when proposing further steps or solving some problem or coordination of works and future steps. So perhaps this. I think it's not so easy to learn how to communicate with people, how to find a way how to solve something, anything. And I'm quite proud of myself that I was able to manage all these issues and challenges and be able to find a way how to connect the team to cooperate in a way that leads to successful installation and successful realization of the demo project.